we'll spend the next half hour talking a little bit about Agile AI and how my team has been taking the latest research into production. So Zineb Laraki, I do go by Z if that's easier. So maybe just to set the stage here, as you guys have all been experiencing, AI is a landscape that's very daunting. Everyone wants it, right? Everyone wants to make their applications smarter, but as customers are trying to implement these different technologies, different AI capabilities, they're facing a lot of difficulties, everything from not understanding how to scope these projects, not necessarily feeling like they have the skill sets needed in-house to build these products, etc. So at Salesforce, the Einstein team is focused on really bringing AI for CRM. It's integrated within the Salesforce platform, it's trusted, making sure that we uphold our transparency and ethical standards that we have. And as Daniel mentioned, so my team really focuses on the deep learning models, specifically in computer vision and natural language processing. So just as a few examples here, everything from image classification to OCR on the vision side, and sentiment intent, as well as NER on the language side. What's really cool about these products is that these are the same underlying products that are used internally by our teams. So the NLP that I just mentioned is used by our internal Einstein bots team to be able to drive conversational AI, excuse me, as well as by our marketing team for emotion detection, for example. And this same technology, these same services are also used by our customers directly. So for example, for automating triaging of cases or survey analysis. And the same thing is true, and one more use case, I guess, that I'm a big fan of is we worked with this visualization company putting to analyze, for example, congressman data. So you can see that the range of use cases is pretty broad. And the same thing goes for the vision side, right? So the same APIs, the same models and services that we make available, our internal teams are using. So for example, Marketing Cloud Social Studios, or our consumer goods team is using it for retail execution. And then we have customers using these products directly. And so I just wanted to share that to give you guys some context, as I'm sharing kind of our process, as well as some takeaways, to give you guys some insights about how the products that we've been working on are being used both internally as well as externally by customers. So with that, let me talk a little bit through how our team works. So hopefully you guys can gain some insights from that as well. So as Daniel mentioned earlier, half my team is the Salesforce Research team, and they're literally focused on advancing the state of the art in AI, for example, in language and vision, which we'll talk about specifically today. So for example, in NLP, we have people working on everything from question and answering, machine translation, summarization, etc. And these teams are working on literally, publishing papers, talking at conferences, and moving the state of the art for what's possible in AI. One such example that came out a few months ago was the multitask question and answering. So as you guys might be aware, in NLP, we tend to break down, the way that we tackle NLP problems, right, usually is by tackling and breaking them down into specific tasks and focusing on one task at a time. With this latest model, we were able to bring in 10 tasks under one model that's able to also generalize and learn from different domains, use zero-shot learning, and really be able to expand from the original training data that's provided into a variety of different tasks, as we saw in the previous slide. So with these kind of advances that the team is working on, we then use that to bake these latest technologies into our products. So for example, I mentioned sentiment or intent. So let's dive a little bit into intent, for example, and how our team is, focusing on taking the latest breakthroughs in AI into some of these models that we are providing to customers. So with intent, for example, we come to our research team, to our applied research team, and we're like, hey, we need to be able to train these models more efficiently, or we need to be able to provide these models in additional languages. And so they work on running experiments, evaluating different state-of-the-art models, coming up with new algorithms to tackle some of these problems. And once they've identified that, hey, we have a solution, then we work with our data science and engineering team to bring these into market. So another great example that we had recently is, our intent model, which is basically a text classification model, allows customers to define, their categories, their intents, provide some data, and then it trains a model on that. Now the negative data set, or the other category, is something that was becoming a very big pain point for our customers, because as you can imagine, for example, in a chat conversation, trying to train a model to understand other or everything else that somebody could talk about that isn't in the scope of what you want your bot to necessarily handle can be very complex and a very daunting task. And so basically worked with our applied research team to devise an algorithm to be able to automate that process. And so use the data that customers provide us to then automatically generate this other or out of domain category out of the box. And so our customers don't have to do that. And so this is working really well. And once we validated that, hey, we have an algorithm that's that has potential from our applied research team, we then work with our data science team to validate it on real world use cases. And then we then pilot it with customers before we roll this out fully to everyone. And this is one example that just got rolled out actually earlier this week. Two more examples, as you guys are probably very aware, oftentimes with these deep learning models, the hurdle of adoption is often with the data and not having sufficient data to be able to train these models. And so right now with our team, we've identified these problems, and so we turn once again to our applied research team and we're like, hey, can we address this problem? And so we're looking right now at, for example, looking at historical chat transcripts and being able to find similarities with examples already are provided by customers, and then surface those to the admin who's training these models to be able to easily add a bunch of examples. Another approach that we're taking is synthetically generating a bunch of data. And so, data augmentation, there's a lot of different data augmentation techniques. Our applied research and data science team, focuses on evaluating different techniques and the trade-offs. And then once we have something that looks promising, we then try that out with a few customers, we build a few models, validate that it works, then we pilot it with customers, and then we roll it out more widely. And same thing, we'll now talk about the vision. It's a very similar process where we basically have people on our team on the research side that are working on advancing the state of the art here as well. So looking at visual description. So for example, if they're given a picture, if the model is given a picture, it'll provide a natural language description of what's in the picture. And so you can see here a little girl sitting on a bench holding an umbrella. And some of the cool stuff with computer vision is you can see where the model is focusing to generate certain words. Another great example here is visual question and answering. So you provide the model with a picture and a question, and the model will then provide a response. And I love this example here because you can see that, what colors are the bananas? Not only can you see that the model is focusing on bananas, it's not understanding of what bananas are, but responds green. And so it's not using, general knowledge about bananas and responding yellow, but really, using the image that's provided here to be able to answer that question. Visual object detection is another area where our team is focusing a lot of work on. So being able to identify objects or parts of objects within an image. Actually, last year we won first place in one of the biggest object detection competitions. And so once again, these latest AI breakthroughs then feed into the products that we make available to customers. So whether that's image classification, object detection, or OCR. So I'll walk you guys through, just as another point of example here, kind of how OCR came about and kind of our process, our journey through taking it from an idea all the way to market and to production and adoption. So a few years ago, basically what happened, we were at Dreamforce, which is one of our Salesforce big conferences, and our biggest conference actually. And I brought the head of applied research with me to a few of these customer meetings. And in multiple of these meetings, we were hearing from customers this demand for being able to read text and images. And the use cases varied a little bit, right? But there was this general theme of wanting to be able to digitize the text that's available, whether it's on VIN numbers, receipts, tables, etc. And our head of applied research was like, "Hey, Z, I think we can solve this better than what's out there in the market." And so I was like, "Okay, great, go ahead. Let's put somebody on this and try to see if we can develop an algorithm, a model that's going to be able to perform better than what's out there in the market that differentiates us on the specific use cases that we care about." And so once we had part of our team working on that problem, once we've identified, okay, yes, we have a solution that could work here, we then worked with our data science and engineering team to be able to serve these models and provide them to our customers. But even within that, we take it step by step. So initially, the first version of our OCR model, was really just about text and images. And we also provide the bounding boxes, so where that text is in the image. And then the next iteration of that was the text in the image and the associated entities. And then the version after that is text and image and the associated cell if it's in a table. And now what we're working on is standard forms. So these forms that are standardized, and it's basically taking OCR to the next level, where you're not only detecting the data or the text that's in the image, but you're also really doing key value pair matching. And so once again here we started with a specific set of standard forms before we move to, okay, now we're working on custom forms as well as handwriting. And so you can see here, from the very beginning, we broke the problem down into smaller pieces and really tried to tackle one step at a time, instead of trying to go directly being like, oh, the big problem is handwriting, we should start there. And so really kind of building our core expertise step by step as we kind of evolve and grow our models from there and our customer demand. And so basically, as you can see with both the vision and the language team, it's really this cycle that's happening where product or customers are coming up with needs, are telling us, hey, can you solve this problem for us? We then go to our applied research team, like, okay, can we solve this problem? Once we've identified that we can solve this problem, then we work with our data science and engineering team to be able to host and serve these models in in production and making sure that, they meet the trust and security standards that we expect, etc. And I've spent a lot of time talking about the research side of things, but there's a lot of work that goes into this engineering and making sure that you're able to host and scale your models as well. And so really this is a cycle that's happening that's really, breaking things up step by step and making sure to kind of have this pipeline that kind of feeds into each other. So with that, so now I've kind of covered our process of how we kind of take things from research into production. What I'm going to do now is I'm going to talk a little bit about Agile AI and really how not only you've seen this in some of our examples, but really how our customers are being successful with deploying AI models in their applications. So I'm assuming everyone here is familiar with waterfall versus agile in development life cycles of products. So for example, if the goal was to build a car, in waterfall you'd start with a tire, then the motor, then and then you'd continue step by step, and a few years later you would have a car that can take you from point A to point B. In agile, right, in agile development, you break that down a little differently, right? Where you're like, okay, my goal is to get from point A to point B. Ideally, I want a car, but I'm gonna start with a skateboard. I'm gonna then, go to a bicycle, motorcycle, and eventually I'll get a car. And the value here is that at each step of the process, you're able to get feedback from your customers, right? So you guys are familiar with this. Now, basically, for AI models, developing these models, taking a very similar approach is really key. So I'm going to walk you guys through a very simplistic example to illustrate this point, but I think has really helped in my conversations with customers, help make things click for them. So let's say that we wanted to create a model that understood all the fruits in the world, right? In waterfall, I would basically start by creating a list of all the fruits in the world. Then I would collect data for all the fruits in the world. Then I would train a model, then I would improve it, and a few years later, or after my project has no longer any funding, you would have a model, right? Now, that's just a very, you're front-loading a lot of work and putting a lot of risk very early on. So doing Agile AI basically is thinking about how can you break this up into what is your minimal viable data sets, right? So yes, I want to get to a model that understands all the fruits in the world, but I'm going to start with just apples and pears. That's the most common fruits. I'm French, so that's the most common fruits that people use. And so I'm just going to start and focus just on those. And what's going to happen at first is I'm not going to have a lot of data. So all the examples I've trained my model on are red apples and green pears. And so the first time my model sees a green apple, it's actually going to say this is a pear. And so what you need to make sure to do here is include a feedback loop, right? So having a mechanism in your process, and depending on your application, this might be at different times, but making sure to have at some points in your process the ability for someone to correct the prediction that the model made and say, actually, no, this is an apple. And so what's going to happen is that over time, your model is going to get data that's more representative of the different use cases that it's going to see in the world. And so when it gets, for example, a yellow apple, even though it might not have ever seen a yellow apple, it'll have been able to generalize enough the concept of apple and pear that it's able to correctly predict that this is an apple, right? Now, the other cool thing is that you can do here is thinking about, we talked earlier about out of domain or other, or sometimes called negative data set, right? So the reality is your model is going to encounter things that, you haven't necessarily trained it on, right? And this happens in almost all use cases, unless you're in a very constrained domain. But what's going to happen here if I've trained my model only on apples and pears is that it's going to try to predict one of these two categories, right? So it's going to see an orange and it's going to say, no, this is an apple. And so what you want to be able to do is add this catch-all bucket, this other category. And so when somebody sends a picture of an orange, it'll be able to categorize this as other, right? And so this is not apples or pears, and it doesn't reduce the ability for your model to understand apples and pears, even though there's a bunch of other fruits in the world, right? It's still able to start understanding and getting a good understanding of apples and pears. Now, the cool thing about this other category is then you can use that as well to retrain, to add additional categories to your model. So just, this is a simplistic dashboard here that you can see. For example, if it was an admin that would be providing the feedback loop in this scenario, right? I'm sorry about that. You can see here the admin, these are here the inputs, the images that the users are sending. This is what the model is predicting. And then this is the feedback that you're giving it. And so you can see here, at first the model was, you were giving it oranges, it was saying it's apples. The admin corrected that to say other, and eventually it was able to predict other correctly. Now, the thing that you can do here as well as an admin is realize that, hey, I actually am seeing a lot of examples of people sending oranges. And so what I can do is create this additional category now in my model that's oranges. And the great thing is I already have the data to seed this category. Now, this is, a very simplistic example that I kind of ran you through to think about, because it really illustrates the point of how you can iteratively grow your models step by step. And this holds true for anything, right? So for any AI model that you're trying to build, for example, for chatbots, what we tell our customers is, don't try to automate everything that your agents are doing. If you start your project by trying to do that, the amount of effort needed to get something out the door is just so big. And so you're not going to start seeing ROI for a long time. And, your sponsors, your executive sponsors are not going to necessarily be happy with your ability to deliver, right, a chatbot, if that's the case. So instead, focus on, maybe the 2 to 5 categories of things that come up the most often. Password resets, changing your order status, or changing your order delivery location, right? So just focus on the top, few items that your agents are seeing more often. So pick just a few, a handful, 5, and build your model there. And with this other category, you're then able to look at that and review that and iteratively grow your model from there. Cool. So that's Agile AI. Maybe I'll take some time here to cover maybe 3 more takeaways that we've seen. So the first one is data. This is often the most, the biggest hurdle that customers have of like, how do I get started? I don't have the data, or I don't know how to train these models. So a few things here. If you have it, I'd say use it, but make sure that it's QA, that you go through the step of cleaning that data. Because if you feed your model data that's not clean, your model's not going to work well, right? And so even if you have the data, make sure to clean it up before you use it. A second thing that we recommend is try to see if you can find data sets online. I do think that we're seeing more and more of a trend of data sets as a channel for people to be able to acquire these data sets online. You can find public data sets that are free, but then there's also in the commercial space more and more data sets that are available for purchase as well. And so that might be a great opportunity depending on your use case. And then finally, creating your data. It's often not as much work as you think it is. The biggest hurdle often here is that it's nobody's job. And so, you kind of get blocked. But if you use Agile AI and if you scope your projects correctly, where you reduce the amount of data that you need to a minimum, creating that data, if it comes to it, should not be as huge of a project as it is. I'll tell you, in multiple projects that we've had at Salesforce on my team, the first iteration of these applications, I've sat in rooms and created the data for training these models, right? So for assistance applications for a bunch of different use cases, sometimes, it just takes taking a few hours, few weeks, and actually collecting or generating this data yourself. So don't be scared of doing that. And then really thinking about the whole pipeline. So thinking about making sure that as you're building new products, that you're storing your data in a way that in the future, if you want to, that you'd be able to use that data easily to train your models. Another takeaway that I think is really important, we talked a little bit about it earlier when we were talking about Agile AI, but this is this notion of feedback loops. It's really important to think about in your process, as you're developing your application, what points will you be able to have, whether it's your end user, whether it's an admin, whether it's somebody on your team, but it needs to be somebody in the process that is able to review and monitor how well the model is performing, and be able to take the areas where the model is not working very well and use that to improve your model over time, right? So add the misclassifications, like correctly label them and add them back into your training data. And then, as we talked about, using this other category to be able to see what actually your customers are wanting to use your model for, and using that other category to be able to seed your data set for additional, categories and labels there. And then finally, the last point I'll make here is that as we are democratizing AI, as we're making it more accessible for everyone to train their models, it is our responsibility to make sure that we're educating people, right? Similar to how we're having, citizen developers, we're seeing a trend towards citizen data scientists, where we're really making it easy to be able to train these models, these deep learning models. But we also then need to make sure that we're training people, not only giving them access to the tools to do this, but we're also training them to understand how their model is performing, and then also what the ethical considerations are of their models, right? Because it is important, it's easy to, now that we've automated a lot of these things, it's easy to just take a bunch of data, click a button, say train your model, and then just say, okay, start using this. But there's a lot of work that needs to go into making sure that your data is representative, that your data doesn't have any bias, making sure that the way that your model is being used is actually being done in a way that is impacting your processes positively and is not discriminating against certain classes or races, etc. So it is our responsibility to make sure, as we're democratizing AI, as we're making it easier, that these concepts in data science around understanding how your model is performing, understanding the intended and unintended consequences of your model, are passed on and are trained, and we educate people on these concepts as well, because we can't just give them the tools and just expect everyone to be able to drive, right? We need to be able to teach them how to drive to make sure we don't have a lot of accidents on the road, basically. And so with that, I think we're about at time. I'll maybe finish by saying, the best way to predict the future is to create it. I know AI has been, hyped and something that we've been talking about for a while, but we are still very much in the early days of starting to see the latest research breakthroughs go into production and improve the way society is run. And so I'm really excited to see how, we continue to leverage these latest breakthroughs to hopefully improving society for the whole of everyone.